In this video, we're going to take a quick break from the data structures that C++ gives you to talk about a way to reuse code that has to operate on many different types. Imagine you're trying to write std vector. To start with, you write an implementation that holds a bunch of integers. Then maybe you write an implementation that holds a bunch of strings. Don't worry about how you exactly implement these. The important thing is that you would have to do this if you were writing them. So on and so forth, right? You'll have to write a vector float class, vector double class, and a vector for every other single possible type. But that's not all. You'd also have to write a vector of ints class for people who wanted to nest them, and a vector of ints, and so on. You'd have an infinite number of classes to write. But that's not even the worst part. What if a user wanted to make a type and make a vector of those? Well, you don't really know what that is when you write the code. You're trying to write a class, but it has to cover a case that you don't know about when you write the code. Obviously, this isn't going to work. For the STL, it would be a miserable failure. They can't possibly know what types users are going to create. To fix this, C++ uses a concept called templates. A templated class or function is a generic implementation that doesn't specify any particular type. Instead, it uses a list of placeholder types that are filled in with a real type whenever you actually use the function or class. It's sort of like a function where your placeholder types are like your parameters. In this context, they're called template parameters. C++ takes in these template parameters and uses them to generate a concrete class that operates using the types you specified. However, instead of just running a particular piece of code, it creates a piece of code. It's sort of like if you had copy-pasted the entire code and replaced the type name, only it does it automatically for you at compile time. Of course, we've actually been using templates for the past two videos. All the types you see on the screen, map, vector, and array, all use templates very clearly. They work with any data type. The way you use a template is by placing type names, or template parameters in general, between angle brackets after the type name. For instance, you have std map of std string and int. You can separate multiple parameters by commas. Vector is pretty straightforward. It's just a std vector of int. A more interesting case comes with std array. Remember that you had to specify the number of elements that could fit in this. This brings up an interesting point. When you're working with templates, you don't have to only specify type names. You can also sometimes specify values. Don't worry about exactly how you write a template for now, but just know that they are very useful. Another thing that you should know is that C++ is kind of bad at generating errors for templates. So, for example, if I have this code, looks fairly innocuous, you'll notice that I'm trying to insert a pair into the map with 5 and 100, where it should take a key type of string, so it should give me an error. You might expect some error that tells you exactly what's going on, but what you get instead looks something like this. It's hard to parse, but let's try to pick it apart. All of this stuff is saying that there is an error in the header file corresponding to map, and really only the thing that you need to care about is the thing that tells you where the error is. This is a pretty good heuristic. Down at the bottom it says badtemplates.cpp:6. 6 is the line number. This is a pretty good way to try to find out what's going on, or at least get some information from the error messages, but in general these error messages are notoriously difficult to deal with. So, to recap, templates are a very handy way for library providers to create classes and functions that could operate over multiple different types, allowing the user to decide which types and which values they want to use. You'll see them a lot in C++, so it's best to get very familiar with how to use them. That's all for this video.